Yeah, my name's Casey King. I think the sessions this morning have just been great. I've enjoyed all of them. So kudos to the programming for the IMTC. It's been great. So I'm going to talk about video coding, past, present, and future from the perspective of both a Codec implementer, which I have been in the past, and also as a solution from a company that builds solutions. And I wanted to talk about two things. The first one is linear change, and that's predictable change. It's processors get faster, the network gets cheaper, codecs get better. So I'm going to talk about that, and then I'm going to talk about nonlinear change. And this is when things, I use the metaphor of burning platforms, and what happens, this is the more interesting really, is what happens when things really change and they have the opportunity to make your company irrelevant, or in some cases make it go away. So I came to this from a very different place. I came from Apple. Was part of the original QuickTime team. Worked on QuickTime for 10 years, and then went to LifeSize. So I thought it'd be interesting to kind of go back and look at video compression from the proprietary side. I've given this talk before. I'm going to start with very small video, go to very large video from 1991 to 2005. And there's been a lot of things since the last time I gave this presentation that have happened. 1080p 60, implementations of high profile, SVC, 4K displays, H.265, new codecs like VP8 and VP9. But I want to go back to 1991. I was part of a group of 10 people sequestered over into a very small room in Cupertino. We knew nothing about video. We knew a lot about 32-bit graphics, and we were tasked with the project to create a new multimedia framework that was possible to run on software only. So anemic processors, 68,000 processors that ran at 20 megahertz. Looking at the numbers now, it's unbelievable how much the numbers have changed, and we've seen that today, from a lot of the presenters. But, data transfers from CDs were just a little bit more than what we did for 720p 30 video, 150 kilobytes. HD drives, 2 megabytes per second. New bus, expansion ports, 10 megabytes per second, a far cry from 5 gigabits. Hard drives were small. RAM footprints, hardly would hold any reference frames today at all. And the codecs that we were using had to run on these types of processors. So the first one we used was one that we invented. It was a color cell compression format called Road Pizza. The nice attribute about it was that it was symmetrical. So even on this type of processor, you could code it and encode it. And the frame rates, or the spatial resolutions, were 160 by 120 at frame rates of maybe 5 or 10 frames per second. I remember this well because on September 3rd, 1991, my son was born. He's 22 now. And QuickTime went to a beta CD, went out to about 3,000 developers 2 days later. So of course, as any good engineer on the QuickTime team, I videotaped the entire birth through about 6 clips on the beta CD. And much to my wife's chagrin, I still show this clip, occasionally every couple of years or so. But the first clip is a 500 kilobit per second, 6 frames per second, 160 by 120.
I was doing a gavage feeding, so about 5 minutes?
Yeah, not more than 5 minutes.
Okay, let's evaluate. We may not have to debate this one.
That's good.
So it's hard to believe now, but this was incredible at the time, back in 1991.
Yeah.
This one?
And the clip was called Pink is Good, and you can tell that I was like any first-time father,
Yes.
totally like a deer in the headlights. So you go to 1998, and video compression had changed quite a bit. There were some new proprietary codecs. There was one from Cinepac, which was a VQ codec. Sorensen had their first version of their codec. Highly asymmetrical, took a ton of time to encode. And the next clip was a Sarah McLachlan music video, 850 kilobits per second, 24 frames per second, 4 times the spatial resolution, 4 times the frame rate. Huge advancement for us. The nice thing about the Sorensen codec at this time was I could scale this almost to full screen, full screen then being 640 by 480 or something like that, and it really hung together much differently than the original Road Pizza codec, which really would start to have a ton of artifacts. But this was a great time back in 1998. Go to 2000. I worked on a codec at Apple. It was a DV codec. It was all the firewall cameras implemented it. A camera then was $5,000. It wasn't a consumer approachable camera yet, but you knew it was, and it solved a huge problem. Before this, we'd have to go to Betacam SP, do multi-pass recording, capture, then encode, and now you could just plug in a camera, get every single frame, and life was great. And this is what enabled iMovie and Final Cut Pro, and which was the demise of companies like Grass Valley. So here's a clip from that. We were big into motorcycles at the time, not anymore. And then at LifeSize. So then I made a transition from the proprietary-based codecs up to the standard-based codecs. And then in 2005, 720p HD at a megabit per second, 30 frames a second. This is only 50% of the spatial resolution. In 2008, 1080, only a quarter of it visible here. 2013, all of the manufacturers have 1080p 60 interoperable high-profile codecs. And so that brings us to 200 times better than what I started out showing you the very first clip of my son. And you guys have all seen great video like this. So the history, according to me, of my role in this started on the bottom. These are the proprietary codecs. Around 2000, I shifted up to the standard-based codecs. And then today, there's some new codecs that are very interesting to us as a system maker, and those specifically being H.265 and VP8 and VP9. We are very, very pro 265. This is our encoder doing a sequence that we've done for 10 years, which is representative of the type of motion that we expect in video conferencing. And this is at 368 kilobits per second, 720p 30. Same clip at 256 kilobits, still is very, very, very good performance. We've taken this down to 100 kilobits, kind of falls apart, down there, but easily we see 50% efficiency improvements for the content that we do. So very, very big fans of 265. Absolutely will build 265 endpoints. VP8, VP9, I don't have any videos. You can find them on your own, or you can make your own. Similar in performance, that's the claim. We heard this morning from Thomas that the claims may vary. It's free. That's the claim too. We don't really care. I mean, at LifeSize, we really don't care. The genie's out of the bottle. It's incumbent on us to be able to connect to these types of systems because it's going to make a big difference, and we're very supportive of VP8 and VP9 as well. Okay, so that's the first part of the presentation, which is the linear change. The second one is nonlinear change and burning platforms, and this is the third year that I've used this metaphor, but similar to the ways that DV codecs and iMovie and Final Cut really destroyed companies like Grass Valley that were nonlinear editing machines that cost $500,000. Similar to the way that Netflix has just destroyed Blockbuster. I'm not sure if Blockbuster plays in Europe, but Blockbuster is a brick and mortar DVD rental company. Just like Amazon has destroyed Borders and bookstores, and just like Nokia, Apple, Android, MediaTek have really put the hurt on Nokia. This was the theme that I've talked about for the past 3 years, and it's really been, I've used other examples, but I've really been using it to kind of frame what's happening to the enterprise video communication industry as we sit today. And if I was to assess the efforts recently in enterprise video communication, then I would say it's not been as successful as what's possible. We have great technology. People don't get to see it enough, and that's a shame. And the new video codecs, while great, don't really change this story. So a couple slides. The last 7 quarters of the industry that we reside in has been disappointing. Negative growth. Calendar year Q1 endpoint market share still strong, over $400 million per quarter, but down 24% quarter over quarter, down 11% year over year. Average selling prices, and we're partly to blame for this because we offer very high performance endpoints at very low cost, but average selling price is down over 10%. Infrastructure even worse, $139 million, year over year down 34%, quarter over quarter 17%, average selling price down 11% as well. So things are getting better and stabilizing, but it's it could be a lot better. So this is all within a backdrop of explosive video use. I think it was Jose yesterday was talking about the amount of voice minutes going down that they're seeing as a service provider. And I was thinking back to, I hardly ever use my phone to actually make voice calls. I use it to connect to the internet, send and receive mail, watch videos, download apps, all these things, get map directions. But I don't use it as much to do voice. So in the backdrop of exploding video, there's huge opportunity for us as an industry to do better. So the impact of new video codecs for us, the good, the bad, the ugly. The good, you've heard it all today, similar perceived quality at half the bit rate, better, and it's a fantastic video codec. Better quality all the way around, and it's certainly the path to 4K in our opinion, and we're big believers in 4K as well. The bad is similar perceived quality at half the bit rate. Bit rate, if you've been keeping up, is very, very inexpensive. We can take 3 servers, throw them up on Amazon, Rackspace, SoftLayer, that can service thousands of users for less than $2,000 a month, which includes enough free bandwidth or included bandwidth to make 15,000 hours of video calls. So the bandwidth from the core infrastructure is very, very, very cheap. So at the edge, a company like LifeSize, we pull 200 megabits of data or internet access into our buildings. Dedicated line, we could do it a lot cheaper, dedicated to us, 200 megabits 200 megabits access at any time, and it costs less than it costs for us to hire a summer intern. So it's very, very, very inexpensive for bit rate. Better quality all the way around, and the argument I'm trying to make is that our customers, unlike 2005, when they would pay up for HD systems, 264 systems, they're unwilling to pay up for 265 or a very, very small increment. The quality is great, but the quality of 264 high profile is very good too. And 4K, even though Oliver showed a picture of a $1,000 4K display, it's still a niche. It's still a nascent kind of market. Today, that's going to change quickly. The ugly part about it is that there are plenty of implementation alternatives for us as a system manufacturer to go off and build these systems. However, they are all too expensive today, and we are pulling for companies like NG Codec and others, to offer us alternatives to bring the price down to what our customers expect. As an example, the picture on the left was our encoding subsystem back in 2005 for H.264 baseline. It included 5 DM642s at a price then of about $75 each. The entire electrical BOM cost for us, not standard cost, just the electrical BOM cost was about $500 for that encoding complex that did 720p30. It also did a second channel of 720p5, but we really struggled to kind of get to that point. The middle one is a DM642 for the legacy codecs 263 and 261. Underneath the heatsink is a part from Oliver's previous company, WWCom. The entire subsystem cost there was about $100, but that one was able to do 4 channels of 720p30 encode, so the average cost per channel of encoding went from $500 down to about $30, an order of magnitude lower cost. Today, it's no surprise in our latest codec, we, as well as all the other manufacturers, use a Netra part, a TI part. This part's capable of doing 12 720p30 channels of encode, and the cost of that is probably less than $3 per channel in comparison to the one on the left. So We have some very, very powerful hardware-accelerated machines with 264 that do high profile, and we're looking to find equally attractive prices for 265. I can tell you, we're not going back to the far left. We're not going to build an endpoint that costs $500 in DSPs to do 265. New codec impact VP8 and VP9, yes. I mean, I'll talk about this. I had the pleasure to be able to talk twice at the conference. So I talk tomorrow about our perspective on the cloud. So I'll talk more about WebRTC there and tell you how you can actually give it a try for yourself and see how you can connect it to our types of endpoints with WebRTC. But we're big believers in this, and we've heard a lot about WebRTC already today. So in summary, the next decade of video codecs has arrived, but we need more than just codecs. They need to be simpler to use. The entire solution needs to be simpler to deploy. It needs to be cheaper. Our customers just need to say it just works. And today, unfortunately, it doesn't work well enough. The optimistic side of it, and I'm definitely an optimist, is video communications and video usage is just exploding. And there's no end in sight to that. And we can all ride that wave if we get it right and we make some changes and we do some things better. WebRTC is the real deal. For us, it's the lowest common denominator to get into an enterprise video call. It doesn't have the same quality of what our customers expect, but it allows a way of entry into the conversation, which is easier than anything else that we've seen so far. So I've got more on this tomorrow. And lastly, I wouldn't count the conference room systems out yet. And I wouldn't at all. I mean, people still want to congregate. They still want to see people face to face like we're doing here today. And I'm going to talk a little bit more about that tomorrow. So with that, I'd like to conclude and thank you very much for your attention. And I know lunch is next.